There are times when I've created a relief that has a vertical edge, and for maybe a couple of reasons I might be concerned about whether or not the tooling that I have is capable of cutting that vertical edge without having a problem. Maybe it's too tall, maybe the size of the tool that I'm using doesn't lend itself to that, and so it might be necessary to apply a draft angle to those vertical sides in order to allow the tool to work its way down that surface. And so here's an example of a relatively simple shape that has vertical sides, and it's quite possible that I may want to apply a draft angle to that. And so I'm going to select my draft angle tool, and it's a relatively simple tool. There's a threshold for vertical height where it decides whether or not a draft angle needs to be applied. I'm going to apply a healthy draft angle here just to make it a little bit easier to see. And I click apply, and what EnRoute does is it examines the relief, and you can see that on those vertical sides it has moved them out enough so that potentially then that's not going to cause a problem with the tooling when it comes time to cut that out. Now, of course, the other thing that immediately comes to mind when you think draft angle is that if you're going to cut it as a mold, that might also allow the molding compound, whatever was used, to release more readily. And so if this was going to be cast as a mold, the draft angle would allow the castings then to release from the mold that much easier. So a draft angle can come in handy in lots of different ways. If I was going to cut this as a mold and I designed it like this, it would be easy at this point then, as we saw in another tool, to invert the relief, and you'd have the draft angle built in for when that was milled out. Again, the tooling may be the controlling factor there that's requiring you to add a draft angle to that surface when you mill it out. So the draft angle has a number of potential uses in this application.